Okay, this is Mr. Peterson, and I'm covering the notes for section 9.3 in Algebra 2. In this section, we're going to learn about rational functions and their graphs. What the graphs look like, what are some of the features to look for, how to find those features. First of all, the idea of a rational function. The root word is ratio, and it means fraction, so you're going to be looking for a fraction bar with some function on the bottom. So here's an example down here where we have a function 3x on top. That would be, by itself, that would be a line. Underneath it would be a parabola, but together they get this graph over here, which is entirely different. So let me just fill in the blank up here. Ratio means fraction, so you're looking for a fraction bar in a rational function. And then you got the numerator, which is called p of x, and the denominator, which we call q of x. And most of the action today happens down on the bottom, the q of x part. Now there's an important feature here. It says q of x cannot equal 0. That's the old you can't divide by 0 problem. Okay, so let me show you some of the features of this first graph here. And this front page is more of an overview than anything else. So what I want to show you is that as this graph gets further to the right, it keeps tucking in closer and closer and closer to the x-axis. It does something similar up here, although it comes in from up above instead of from below like that one. Now I'm going to show you how to graph this. You simply go to your y equals key. I'll clear out what's in there. Type in your negative sign. You want to encase the numerator in a parenthesis, and then do the same with the denominator. And I'm going to go ahead and use the window settings that are over here, although our picture is going to look a little different because of the shape of the screen. So this goes from negative 12 to 12 in the horizontal direction, and from negative 5 to positive 5 in the other direction. Touch graph, and you'll see this show up here. And it's a little hard to tell, but the further to the right you get, the closer it gets to that x-axis. One way to tell that there's what we call a horizontal asymptote through the middle here, is to set your calculator in ask mode. Then go to your table. I've got some things in here. Let me get them out of there. And I'm going to type an x value that's way, way over there to the right, maybe 500. And you can see that you get a negative value, which means you're underneath, and it's very close to 0, so you're getting closer and closer to the x-axis. Now if I go the other direction, you're going to get one that's above the x-axis, so negative 1,000, and you can see that it's very close to the x-axis, 1,000ths above it. Okay, so let's hit graph here and see that graph again. And now let me transfer over to the paper version, and I'm going to draw the horizontal asymptote. These often have a horizontal asymptote. And this one's the x-axis, so I put its equation right there, y equals 0. Okay, another one here is, and this one is 3x over x squared minus 16. And it features a horizontal asymptote at the same location as the other one. So let me get that drawn. And you can see that as I go way over to the right here, it gets closer to that x-axis, and this time on the positive side of it. As I go backwards on this thing, it tucks up underneath it, so it's a negative value that gets closer and closer to the x-axis. But it also features two vertical asymptotes. There's one right here, and another one over here at x equals negative 4, that vertical line, and x equals positive 4, that vertical line. And what happens at those locations is the function avoids them. It comes here and it goes down closer and closer to it, but it never touches it. If I were to go backwards on this thing, I would see the same thing here. It's going up and up and up, but it never touches that negative 4. I'll explain that in a minute. So you get this action here where one arm goes up and the other goes down. Sometimes you have both of them going up or both of them going down, but it avoids those locations. Well, let's see why. If you put an x equals 4 in, the top is fine. 3 times 4 would be 12. But if you put it down here, it's undefined. 4 times 4 minus 16 would be 16 minus 16. It zeroes out, and it's undefined at that location. That's why it never touches it, is because if it actually gets to x equals 4, this ceases to be a number. Remember, dividing by 0 doesn't even give an answer, not even 0 itself. Same thing's going to happen at negative 4. Negative 4 times negative 4 is 16. 16 minus 16 is 0, and that means that at this location, the function is undefined. Okay, so you might think you always get vertical asymptotes at the 2 places, or 3 places, or maybe even 1 place, any place that it's undefined, where the bottom zeroes out. That's not the case. Sometimes you get what's called a hole. So this is a graph that has both a vertical asymptote at x equals negative 1 and a hole at x equals 3. It's undefined in both locations, but one of them doesn't give a vertical asymptote. This one here is a hole. It's just simply undefined at that location. Now I'm going to go ahead and on the next page teach you how to tell the difference between the two, but here I'm just going to show you that it's undefined at these 2 locations by doing this on the graphing calculator. And the vertical asymptote will show up really easily. You'll see it, but the hole, it kind of hides on these calculators. So I've got it graphed here. I'm just going to use Zoom 6 to show you this. And this behavior, I think I typed it wrong. Hang on. What did I do wrong here? X minus 3. Oh, I see. It's got to be a minus there. Okay, now it's fixed. Okay, so here it comes. And you can see that it's trying to avoid this value of x equals negative 1. So it dives down or comes down alongside of it, but it never really gets there. And that's this vertical asymptote there. If you hit the trace key and you hit negative 1, you'll see it's undefined there because the y doesn't show up. The same thing happens over here, but you can't see it on this graphing calculator. If you do trace and then 3, you'll see that it's undefined there. Now if you go slightly to the right or to the left of 3, it pops back in, like 3.01 actually gives you a value. And by the way, this is how you can tell what height that you would use to make that little circle that you use to graph a hole. It's undefined, there's no value there. If you come and just go a little bit to the right of it, or maybe 2.9999 to the left of it, you can see that it's about a quarter up. And you're actually not graphing the location, you're just graphing something a little bit to the right or to the left of it. But if you go 3, you can see there's nothing there. Okay, there's no graph there. We'll pick this up on page 2, and on page 2 I'm going to show you how to find these holes and vertical asymptotes and tell the difference between the two.